Hello everyone, this is Leadway tutorial. Today we'll be dealing on resolution and equilibrium of forces. For this topic we should consider the following: what is force, equilibrium of forces, joint and equivalent forces, resultant and resolution of forces. The resultant and the resolution of forces is the principal part of this topic. So what is force? Force is a vector quantity. It is the ability to pull, push, twist, or accelerate a body. That leads us to equilibrium of forces. The equilibrium of forces states that the state of a body to be at rest in which the resultant of all forces are equal to zero. For this, it is the state of a body to be at rest in which the resultant of all forces are equal to zero. This implies that for all forces acting on a system, the resultant of the forces are always equals to zero. That is, the summation of forces acting in the is equals to zero until you deal with the resultant. The result of a system of force can be defined as a single force which will replace the given system of forces and produce the same effect. This means the resultant of a force is that single force, a particular force that will act on a system and produce the same effect which individual forces acting on that particular system will result to. So let's get to the second aspect, which is the joint and the equivalent forces. For the joint and equivalent forces, we'll be dealing with the forces acting on the system, its symbol, and the equivalent forces. For this, we're dealing with 7 kinds of joints with their equivalent forces. The first one we'll be dealing with here is the roller joint. This is a symbol of the roller joint. And a roller joint produces an equivalent force of vertical forces, just like this. There's an equivalent force for a roller joint. A roller joint has a similar equivalent force to what a rocker. There's a symbol of a rocker joint, which produces also a vertical force, like this. We also have a frictionless force or frictionless surface, which is represented like this, and have a vertical force just like the rocker and the roller joint, as you can see. Now we have the fourth one, which is we have the short cable or the short link. This kind of link in a system produces a force which is directed along the link. As you can see here, this force is directed towards the link. This is a link. The force is directed towards the direction of the link, as you can see. So we have the next one, which is a frictionless pin or hinge. A frictionless pin or hinge has two reactions, one acting vertically, the other acting horizontally. If the pin or hinge are a system of force acting A, the equivalent forces which will be acting on the vertical and horizontal components. Say, let's assume we have a our horizontal plane is taken to be X and our vertical is taken to be Y, as the case may be. That means the force acting horizontally will be AX and the one acting vertically will be AY. That's just it. Then we have a fixed support. The fixed support has the same as two unknown force and a couple. The difference here is that a couple is attached to it. There's a couple, and it also have an horizontal force acting, call it AX, and a vertical force, let's call it AY. That's just it. And we go to the last one, which is a rough surface. This also have this is a symbol here. It also produces two force, one acting horizontally and the other one vertically. If this is the vertical plane and this is the horizontal plane, we can call this one AY. If we call the joint here, joint A, it's going to be AY and it's going to be AX. So that's how let's apply this to an example so that we could get a little understanding about what we're saying. So we consider the system below. If you can see, there's two joints here. by comparison with what we have here, this is a pin. There's a pin. As you can see, it is a pin. It's going to be a pin, and as you can see, it is a roller joint. A pin and a roller joint. And you can look at the equivalent forces. A pin has two reactions, horizontal and vertical, while a roller have a vertical reaction. So, to draw the free body diagram, you can have the free body diagram FBD. Something like this. There's a body from point coming down to D. Call this the A, the B, and the C. Oh, to figure the equivalent forces now. For pin, we know we're gonna have two forces, one acting vertically and the other one acting horizontally. So the vertical, we're gonna be having By. From the horizontal, we're gonna be having Bx. So this has replaced this pin. The force here is equivalent to this pin acting in this mechanism. So when we have the roller have a vertical forces acting here, definitely we're going to be having something like dy, so which has replaced the roller. So this is just a solution to the question. And if the force is given here, for instance, then you can resolve and probably have the resultant forces. So that's just how it works. So let's move on to the resolution of force. We'll move to resolution of force. To have a resolution of force, we say a single force can be resolved into several forces called component. For example, the force F acting at an angle theta can be resolved into vertical and horizontal component as shown. You can see, consider the figure below. This is a force acting on the system. This is the angle theta. There's a force. For you to resolve this force, there is always an horizontal component. A horizontal component and a vertical component. So as you can see, the vertical component here is indicated as f of h, and the vertical could be represented as f of v. You can looking at the principle above is to resolve the force vertically. For vertical, we have f sine theta, that is, and for this horizontal, we have f cos theta. The principle here is that when force is inclined to the horizontal, this is what I mean by horizontal. This angle is inclined to the horizontal axis, so we say it is inclined to the horizontal component. Here we go. When force is inclined to the horizontal, then the summation of forces acting vertically is f sine theta, and this one is going to be f cos theta. And the basic way we're getting this is just very easy. You can actually know that with your trigonometry Pythagoras theorem. When we get down here, we will also have a force acting vertically. This is where it is acting vertically. If you look at it, this is a vertical force. Now the angle is inclined to the vertical force, so we say it is acting with inclination to vertical. In this case, we're going to be having the reverse of the component, where your force vertically, for vertical, you will be having the force to be what? Reverse case, which will be f cos theta. And for the horizontal, we'll be having f sine theta. So for this, it is just as easy as this, but for better understanding, we'll be working on two examples in this video for the knowledge to be fully acquired. Let's take this example. If we have, find the resultant of the system below. As you can see, the first thing you have to know is the inclination of the angle. We have angle 15, which is for the force 60 Newton acting with respect to the inclined to the it's inclined to the horizontal. We have 40 Newton, which is inclined to 45 degrees. So to get the what, we have to look for the resultant. Definitely to get a resultant, we have to know the horizontal force and the vertical force. So summation of the vertical force should be 0, and summation of the vertical force should be 0. So what we're saying is the summation of the forces acting horizontally is to be 0, and the summation of the forces acting vertically is to be 0. Now let's take it horizontally. For horizontal, we're going to have, we said horizontal, we recall that from the previous explanation. We said if it's inclined to horizontal, we have something like f sine theta. For vertical, as I'm saying, and F cos theta for horizontal, as the case may be. Now we're going to be taking this for horizontal component. Now we're going to have summation of f of h to be equals to F cos theta. So we sum the force here, and we also know that everything here is going to be equal 0. That's it. So we go 40. We have 40 is inclined to angle 45. As we're going to have 40 what? Cos 45 degree. Then you add it up, which is you're going to have plus. You have the 60 Newton cos 15 degree. That will give you the horizontal component process. That should give you the horizontal component. So if you point 86.2398 Newton by approximating to 4 decimal places, you have something like this for your horizontal components. Similarly, for your vertical components, you have summation of the forces vertically to be equals to F sine theta equals 0. And the force here in this case we're going to be 40 sine 45 degree plus 60 sine 15, mistake here. Here is going to be 40 cos 45, 60 cos 15. Okay, we are right here. For the vertical component, we're supposed to have 40 here, 40 cos 45 and 60 sine 15. So we have this. I'm pressing your calculator. You're going to have something like, I think 43.81, 34 approximately, in Newton. So you need to get the resultant. The question says you to find the resultant force. To get the resultant force, you can have a free body diagram. Here's a vertical region. You're going to have 43.8134 Newton here, and here, which is horizontal, you're going to have something like what? 36.2398. Now what you've just done is just to resolve this component into a single system of forces. So before you can get the resultant, you have to look for it to make it a single system of forces so that you can get your resultant. So you can continue like this. You get 43, and to get the resultant 43, we have it to be using Pythagoras theorem. A mathematical approach. For instance, this place is going to be your hypotenuse, and the square over in this, that the square of your hypotenuse is always equal to the square of the two sides, addition of that side, which is adjacent square plus what? Opposite square. So in summary, what you're going to have is when you have 43.8134 square is equals to, we're going to have plus this 86.2398 square is equals to what? The hypotenuse. Call the hypotenuse the resultant, half square. So if you add these ones together, if you look for the square of this with the head of it calculator, you're going to have r squared to be equal to 9356.9171. Then you look for the square root of this to get a resultant, and you're going to have, which is going to give us an answer to be in what? Newton 96.73. So this is the steps and the solution to this problem. These have solved and resolved this system into a single system. Now, from the definition of resultant, which said is a single force that will give equivalent what effects So with this force 96.73 will give the same effect which these two forces has given to this system. So that has confirmed the definition of the resultant. So let's take one more example. So you can just round up today's class. A cola. Now the question says a cola of mass 10 kg, which may slide on the vertical rod, is subjected to the indicated forces. Determine the additional force required to keep the cola stationary and its direction, assuming there is no friction at angle 30 degrees. Now the first thing we have to do in this is to draw the free body diagram. Now to draw the free body diagram, now we're going to have, let's say, the free body diagram FBD. Now we have something like this. This is 80 Newton. 80 Newton. We have something like this. This one is inclined to the right. We have theta, which is equal to 30 degree. 30 degree. When you come down here, we have theta. This force, I think this force is what this to be 150 Newton. So it's gonna be 150 Newton. So here it's gonna be 30 degree. Here it's gonna be 100 Newton. Oh, now, and given a system of mass which is equal at 10 kg, and that means this place is 10 kg. Now let's take I know that the force is mass times what acceleration, gravitational acceleration, which is g. Now let's take our g to be equals to 9.81 meter per second square. So that the force acting here is going to be what, 10 times 9.81. That's going to give us 98.1 Newton. That means the equivalent force here is going to be 98.1 Newton. So we can just now resolve, and this said determine the additional force required to keep the cola stationary and its direction. That means you should calculate for the resultant force. What it's saying here is to determine the resultant force required. So to do that, we know we are just like the earlier sub question, we have to make all our system to be a single system before we could get the resultant with the what Pythagoras theorem. So let's go. We have for horizontal component, we know that. Now there's something I want you to take note here. There are two ways we can solve this question. Is either we resolve it directly the way it is, or we incline everything to one particular direction, either horizontally or vertically, just like we said in the early what we're talking about here. We're talking about the horizontal and the vertical components. So we can just solve it the way it is, or resolve it back, everything back to horizontal or vertical, as the case may be. So I will be solving it directly and as well resolving it to one direction. I will choose horizontal. I prefer horizontal. So with this summation of forces acting horizontally to be equal to 0, we have this is a vertical forces inclined to 0. You cannot compare it with horizontal, so it is going to be a vertical. So like I was saying, if it's to resolve horizontally, we know that it's going to be what, for this system we have to resolve to horizontal coordinate, along x. So we're going to have something like, you know, it's what, this is 80, 80 is going to be 80 cos 30 degree, and this angle is inclined to vertical. That means it's not going to be cos here, it's going to be sine, and this is acting in a positive direction. It's going to be 150 sine 30. So if you had that, if you press the calculator, it's going to give us 144.28 Newton. That's for the horizontal component. Now we get for the vertical component. The vertical component, yeah, so we're talking about the vertical forces. So as the case may be, we have this 100 Newton which is acting directly. We have 100 plus this is 98.1, then plus we have this, it will be 80 sine 30 plus this is going to be 150 cos 30. So when you add everything together, you're gonna have, with the head of the calculator, you're gonna have 368. Yeah, this is gonna give us 268 Newton. So you're gonna look for the, now you can now look for the resultant first. So you have horizontal here. The horizontal is 44.28 Newton, and this is 368 Newton. So let's take, if you have to take the resultant here, you're gonna take the Pythagoras. You have r squared to be equals to what? The square of the opposite side. You have 368 squared plus 144.28 squared, and that r squared is gonna give you 156,240.7184. If you take the square root of this, you're going to have 156,240.7184. That's going to give us 395.273 Newton. So that's the equivalent amount of force, the resultant force acting in the system.